All right. Welcome back to the Protocol Town Hall. It's a periodic guest talk series focused on protocols and protocol research. Today, we will be speaking with Chenoe Hart about her Summer Protocols research project entitled Addressable Space, which was just released on summerprotocols.com yesterday. So go ahead and check it out there. You can find that research and the program calendar for the Protocol Town Hall, along with other informations about the Summer Protocols and the Protocol Kit at summerprotocols.com. We also have our main avenue of communication, which is our forum at forum.summerofprotocols.com, which will also be the place where we will host any conversation surrounding this talk. So, yeah, with that, I will go ahead and pass it off to Venkat to introduce our speaker today.
All right. Thanks, Josh. And just to reinforce what Josh said, if you're posting comments and want to participate in the discussion, please do so on the forum website, not randomly on like the live stream link or something. It's easier for our speakers to respond if the discussion is in one place. Yeah, really excited to introduce Chenoe's talk and topic. So I think we've known each other for several years before Summer of Protocols, and Chenoe has actually presented at a conference I used to run several years ago called Refactored Camp, and I believe that's where I first heard this general line of research on how corridors work and how rooms are numbered in buildings. It's kind of like I never even thought about it, that at some point somebody had to decide to put numbers on rooms, and it was a very interesting train of thought. And I'm glad to see it's turned into a full-fledged research project. So over to you, Chenoe.
Hello, everyone. I'm Chenoe Hart, and thank you, Venkat, for the introduction. And I'm an architectural designer and researcher, and so my project, Addressable Space, is discussing, as was mentioned in the introduction, how our built environment is remapped in terms of information. So I will set up to share my screen. Let's see. Okay, that should be, I believe, the shared screen. Okay. Okay, so to start, so first of all, I want to thank the Ethereum Foundation and the Summer of Protocols program for the incredible opportunity to do this research. And so this idea starts off by considering several significant trends which have happened in the built environment. So our first part of the talk, spatial arrangements. If we look at the last 15 years of technological development, we can see that increasing amounts of computer technology involved in coordinating various activities in our physical world has appeared, from on-demand delivery apps to sensors for tracking things like the capacity of cars in a parking lot, and then emerging technologies such as delivery robots and driverless cars. So our built environment is becoming increasingly mapped, networked, and sensor-filled, which raises new questions about the role of information in the built environment. So one way of looking at the nature of information is that since computers perceive everything in the world through a mediated condition where they have to input information into their sensors, and then the sensors for, say, a robotics system or a logistics network, then that information gets converted into data, which is different from the world that we see firsthand. In the words of James C. Scott, writing in Seeing Like a State, the information has to become legible to the system of the computer, or indeed to a system of protocols. And so if we take the metaphor, for instance, of our kind of view of a city like we would see firsthand or in a photograph, and then the way that data is documented in the yellow pages, for example, if it's like a book, then or a database, it can be flipped through and potentially rearranged. You're not traveling through it in a linear way. And the history of other ways that we navigate the built environment in terms of information, such as building addresses, also reveals similar patterns, prominently emerging, in fact, in the 18th century. So in the 18th century, European governments, as cities were expanding, began enumerating them based on the origins of more universal addressing systems, often replacing previous, more informal associations of buildings with specific names. However, these addresses were not directly a system which corresponded with physical geography. Instead, the governments might decide to number everyone's houses for purposes of keeping track of their population for a purpose like military conscription or tax collection. And as a result, often over time especially, the addresses would not necessarily need to directly correspond with geography in a way that would allow a person walking through that space to navigate the built environment. Instead, for instance, in the 1770 Habsburg house numbering system, once the initial numbers were made, then if several buildings got combined at a later point in time, you would still have the old house numbering that wasn't updated to reflect the new physical geographic conditions. So there's conditions, or then the 1790 post-revolution French house numbering system, where the houses were numbered according to different relatively arbitrary sections in the city. You might have one street where two houses had the same number if the street crossed between two different sections. So it was an arbitrary system, not intended to be navigated by humans. And then for an example of that, we can see the old house numbering in Prague, for instance, consists of the top older number is called the conscription number, and that's from the 1770 Habsburg system. But then in the 1860s, there were reforms where they had a newer orientation number, which could be used to more directly navigate physical space. So then this raises questions about what does an arbitrary address inside a building look like? We typically expect buildings to be relatively stable parts of our built environment, designed to provide shelter. But they also have an abstract system of labels. Every floor is an informational label, which raises the question of whether, like a city street, we could potentially rearrange those labels and create new kinds of imagined virtual buildings if the floors were rearranged. And the answer is we are already doing that and have been doing that for a long time. One example, which will likely be familiar to many readers, if you go into most elevators in Western culture, they're likely missing a 13th floor. So every building which employs that condition has its actual floor count slightly shifted from its virtual floor count. And there's also more dramatic examples of that. So in several East Asian languages, the number 4 is pronounced similarly to a word associated with death. So buildings may eliminate the number 4 like we eliminate the number 14. Well, in the case of the One Burrard Place building in Vancouver, Canada, a new condo development, which was marketed towards the city's Chinese population, the developers decided to employ that floor numbering system to such a dramatic extent that by eliminating all the floors that contained a 4 in or ended in 4 within a 50-story building, it ended up in fact being marketed as a 60-story building instead. So that's a significant difference in building height, and first responders in the city became concerned about whether it would be safe to navigate such a building in an emergency. So the city banned the practice of eliminating those floor numbers. Then there are other examples of hidden floors in buildings which are more subtle. So many skyscrapers, a particularly easy to identify example is the two towers of the New York's former World Trade Center, have dedicated mechanical floors. You can see them here as the dark bands on the building's facade, which would house HVAC and mechanical systems such as motors or controls for the building's elevators. So when you travel through any building which has a mechanical floor, or several mechanical floors, and many taller buildings do, then those floors may not necessarily appear on the list of floors that you're presented with as a passenger on the elevator, or they may be restricted access floors. So that's another common example of how buildings present selective fictions to us of what spaces we see on the outside of the building versus the inside when we're traveling through it. Then another example in which the idea of mechanical floors was developed to a more dramatic extent involves the controversy with mechanical voids, which is a term that became used to describe an oversized mechanical space in the 50 West 66th Street residential condominium, which was proposed in the 2010s in New York. So the first proposed version of the design had a single mechanical space in the building that was 160 feet high, all empty, in order to make the building taller so that apartments in the building could be placed on more desirable higher floors. There was controversy over this development, and the city created new restrictions on how tall an individual mechanical or other empty space could be. And this was a diagram created by the New York City Department of City Planning, showing what they considered to be better practices that should be used instead. So not having these buildings with excessive unoccupied space in them, which again would not be presented to typical visitors of the building when they're traveling up or down in the elevator. So one conclusion which we can think about from looking at those buildings is that it's practical for elevators to be used to travel relatively inefficiently through physical space. And that happens because automation allows us to abbreviate travel distances. And that can be seen in a variety of automated systems. Another example can be seen with the genre of photographers attaching LEDs to their Roomba robots and doing light paintings where the robot would travel around a room in a long exposure photo over time. And you see that it takes a relatively inefficient path to navigate the room and get you different points in it. But that's considered acceptable for these systems because they're automated. After all, the goal of a robot is to do labor, which humans aren't necessarily going to do. So this creates a new paradigm in which distances in physical space mean something different to computer systems and network systems of various kinds, like those that would be controlling a robot or an elevator. And an elevator also, especially with modern technology, is increasingly becoming a robot on a linear fixed track. So to look for another example of how automation has changed our paradigms around physical space, we can look further back in time to how buildings were constructed before elevators. So this is a typical example of a typology of housing common in Paris, where similar paradigms exist in other European cities where the second or third floors of the building, which were above the sort of hustle and bustle of the street level, but not too high up to be inconvenient to travel to on stairs, were called the piano nobile, and those floors had higher ceilings and were considered the most desirable space where the owner of the building would reside. Then on the higher floors, you have less desirable spaces. They take more flights of stairs to access, culminating in, at the very highest level, the garrets, low ceiling spaces just below the roof where the servants would live. And so now the elevator reversed that hierarchy, and we see modern buildings like, particularly exemplified by the types of tall, slim condo towers now rising in New York, where high floors are desirable. And of course, a penthouse is often the most desirable floor in a residential building. So as another metaphor for describing this condition of spatial navigation, we might consider travel through a building on a stair to be like a tape, an analog medium, whereas the elevator allows us to have random access to physical space. Of course, that doesn't completely work at anywhere near the same speed as a memory chip, since the elevator is still a mechanical system, but we do have precedents for mechanical systems being used to access digital information in the form of a hard drive. A hard drive might require some seek time to access the digital data, but it's quick enough that it can effectively operate like a digital system and be used for computing. So then, thinking more about the nature of physical space and digital systems, another aspect of these spatial conditions is that when space gets enumerated, it becomes more specific. So if you think about an analog system of numbering, you could have any number of points along the curve of, say, a sound wave, which then, when the medium becomes digitized or recorded, get broken into these smaller finite steps. So similarly, with the built environment, we see that a potentially infinite variety of different elevations that you might encounter on a sloping hillside in the natural world is a different type of spatial occupancy from buildings which are divided into discrete floors. Each floor is a specific vertical location in space, which would be harder to specify with the gently sloping hillside. And we also see that that principle has been relevant to the historical evolution of elevators. So the earliest elevators, common in the 1800s, required an operator to control the elevator with a manual hand crank, like you see on the left image. And so in order for an elevator to travel whatever distance, the operator would have to hold the crank for that long of a period of time. And operating an elevator in that way was also a job that required some skill. In order to stop smoothly, the operator had to anticipate in advance when a moment before the elevator would arrive at the floor of its destination, and let go of the hand crank a certain amount of time beforehand in order to allow the elevator to stop smoothly and to stop at the same level as the destination floor. So the fact that those elevators arrived at specific, discrete, quantized floors in a building was not something that was taken for granted. And furthermore, also, the operator had to pay attention as the elevator was traveling past different floors in the building. So there was an awareness of the other floors and their context, which would make it relatively more challenging, for instance, to eliminate a lot of floors in the building's height. Around the turn in the early part of the 20th century, as elevators gradually began to incorporate more advanced electrical interfaces involving buttons, now there's literally a digit involved in accessing different floors. And then we get into a paradigm where it becomes closer to what the architect Rem Koolhaas has hypothesized about regarding the nature of elevators, in which he was inspired by the idea that each level in a tall building could become its own discrete entity where different activities could be housed. So his precedent for that, which he was inspired by New York's Downtown Athletic Club, constructed in 1930, had different levels of activities on different floors. So for instance, one floor would have a swimming pool and another floor would have a gym. He was inspired by the idea that separate activities could exist on different floors and then become their own defined spaces. And that's also different from previous historical paradigms of how buildings work and plan and how we think of rooms in a building. So according to the architectural theorist Robin Evans, in his analysis of the nature of corridors and rooms, in the Italian Renaissance, many residential buildings would have multiple entrances between different rooms. They were all connected together in kind of an unfolding matrix where to access one room in the residence, you would walk through other rooms. And there were no significant designated corridors allowing you to access multiple different rooms from the same space. So this had the effect of causing multiple different people from different social classes in the building to interact with each other in new ways, in different ways, as they would go through different rooms in the building. So the owners of the building would be more likely to interact with their servants when you had to travel from one different room to access another room. This changed with later British Victorian spaces, where many rooms began to have fewer entrances, as we can see in the plan of this house, which was also mentioned in Robin Evans's analysis. As you can see, many of the rooms only have one door instead of 2 or 3 or 4. And that created the modern concept of spatial privacy within this type of house, where now a door could be closed off from other people, and it became its own discrete place, suitable to more specific types of activities than before. So we are starting to see here with this room, there's an increasing number, or with this house, there's an increasing number of labeled rooms. Rooms gained more types of dedication to specific activities. And then in the plan of this larger residence, we see that there's a wide variety of different activities and increasing segregation, for instance, in the house by gender. So if you look at the plan and these zoomed in details of it, there's a separate women's stair, young ladies stair, and bachelor stair. So spaces became divided into more and more specific functions. And we could say that this type of discrete granular categorization created more specific spaces. And this type of labeling is an increasingly digital system. So then that brings me to, if different people in those different places, in those different areas of the house, had different experiences traveling through the house with increasingly segregated spaces, then what types of narratives did that create? Because it created some deliberate ones potentially. So one precedent for thinking about this, again, referencing Rem Koolhaas, drawing from his previous background as a filmmaker, he has said there is almost no difference between architecture and film, since they both use the same principle of montage, or in other words, cutting between different pieces of film footage to bypass inconveniences between the main scenes that you want to feature in a narrative. And that's a similar type of discrete connection as to what we would see when we walk through a corridor in a house that only shows us some types of rooms and spaces in the house, but not others, or when we travel certain places in an elevator. So thinking along the lines of film, this creates some strange architectural conditions. Another property of film we see with the precedent of spaghetti westerns, where movies in in the 1970s, Westerns were filmed in areas of Europe, such as Italy, and in the case of this image, Spain. This is a Spanish film set that was used for The Good, the Bad, and the Ugly, and A Few Dollars More, where the set acts as a stand-in for the American West, which is being portrayed as the location in the story of the film. So one place can act as a stand-in for another place if it has similar symbolic content. And we see then there are some other symbols like that operating in everyday life around us whenever we travel past a fast food place, where since chain stores are all designed to be very similar to each other in experience, and the experience for customers, one store can act in effect as a substitute for another store. So when you travel to one chain store, your experience of it is probably going to be informed by your previous memories of visiting previous chains in the past. And if you're riding in a car on a long road trip, you're more inclined to want to experience familiar, predictable spaces in some cases, instead of finding a new location. So chain stores, in effect, and chain restaurants work based on our memories. So another example of this would be if you just imagine seeing the outside of a Chili's restaurant. Since they have a distinctive interior experience, you can probably visualize what it's going to be like to experience that space inside. But this principle creates some issues with navigating physical space, where if you're traveling along a highway and you see certain signage informing you about the food available at different exits, these signs may or may not show all of the locations available at that destination where you could go. There might be other restaurants left off of the sign, which you wouldn't necessarily know about when traveling past at high speed. So the familiarity of fast food limits our range of choices. And this also occurs with our own mental process when we are using a map and the GPS on our phone to look for a place to eat while traveling. So if we decide to search for a particular type of fast food chain that we're already familiar with, which we'll do, or which we are likely to do since those are places we remember, then in effect, we're getting a limited view of what types of locations to eat are available in a particular place. So you can search for the familiar fast food chain because you remember it, but you can't search for a competitor or a small business that you don't remember. And smartphone apps to promote and help customers use and these businesses build on that principle, where many of the types of advertising available for them in the Apple App Store promote them as a way to quickly find a familiar business and promote the idea of conveniently accessing the food from that business. So they're building on a sort of implicit relationship and connection with a brand, which again, the idea, I mean, you would have apps likely for some businesses you might visit, but not others you might consider. So in effect, these networks and these informational labels are like the equivalent of bypassing net neutrality in physical space, in that certain destinations, just like certain website addresses, are easier to access than others. And the modern online app-based food infrastructure has also created some other types of spatial distortion, particularly prominently in the form of so-called cloud or ghost kitchens, where when you're using a food delivery app, you can potentially encounter businesses on the app which market themselves as providing one type of food, but are actually being cooked in a different type of business. So one cloud kitchen could cook several different types of food under different brand names, even though they were all being cooked from the same location. Now, during the pandemic, that recently happened. Some existing brick and mortar businesses got into this model with the idea of also cooking and selling food under alternative brands. So when a consumer saw the possibility of ordering from a brand called Pascali's Pizza in a delivery app, if they look at the website, you see some signifiers of perhaps an independent or a health conscious business. There's graphics imitating what looks like paper and handwriting. They imagined they were getting a certain type of experience, perhaps based on the quality of the food they would receive. And it looked like a relatively small business. In reality, Pascali's was actually being produced and cooked by Chuck E. Cheese, which is a surprise for customers who likely would not have otherwise planned on ordering from a chain associated with children's entertainment. So these spatial conditions can disrupt and distort consumer expectations when one space pretends to be another space. Now, this type of radical interchangeability of space also has some connections with virtual spaces more generally, such as those we might encounter in a game, where games are similar to cinematic montage, the type of condition that allows these physical spaces to be represented in interchangeable ways. Only in a game, you can more literally jump between different locations since they're being loaded from different files, which again are randomly accessible. So then we get conditions like, as shown in the image, the mechanism or protocol of teleporting in virtual reality experiences to quickly travel between different distances in space, or large distances in space. So then a characteristic of those virtual worlds, similarly to what we've seen in physical space, is that those rooms loaded from files can again be interchanged. So a quote from the game designer Michael Nishi, who he created an experimental game called the Cube Club, which was part of a larger project called the Common Tales Experiment, where it contained a room where, in his quote, two opposing doors from his quote about the game, two opposing doors from one virtual room lead to similarly opposing doors in a different room. So when an avatar leaves the first room through the northern door, then the avatar will enter what's seemingly an adjacent second room also through what appears to be the northern door. But then the southern doors of each room are also connected the same way. So you could not, in fact, travel through such a connection in physical space. Normally you would go from the north door of a room into the south door of a room instead of the north door of the next room of that room, if the southern door of the room was north of the northern door. So in this way, the virtual space allows for two different spatial conditions to exist in the same place and be walked between. And so there's precedence in virtual worlds for thinking about these strange phenomena we see in physical space. Now, if we go back to elevators are also acquiring increasingly digital interfaces, which might resemble a digital interactive system like our computer. So many smart elevators, as you may have encountered in taller, newer buildings, might have a touch screen where you access the numbers of different floors in the building, just like as if you were typing on a smartphone screen. And these types of interfaces can also have additional features like secure access to different parts of a building. Here's an example of an elevator interface. This was implemented from what I've seen in buildings that were built in the 2000s. So the information available about it online was this relatively low resolution image, but each floor button that's grayed out as inaccessible has a little lock icon on it, just like a file you might see in your computer's file system. So the floors are being visually treated as though they are files. And so this creates new types of conditions of selective spatial access, which are represented through the metaphor of something we usually think of as digital, which brings me to the issue of user interfaces and skeuomorphism. So the most direct way of accessing an interface on your, or accessing code on your computer, or one very direct way for the typical user, the most direct way that they might be likely to encounter, would be to use the computer's command line to directly manipulate files. So, and of course, that happened with many computers before the advent of graphical user interfaces, which often tended to use icons based on metaphors from the physical world. So a file in a computer would be in a folder that you clicked on instead of being something you typed to access in the command line. So you had this example, this representation of a physical object to help you make sense of the internal structure of the computer. And then that trend developed over a number of years, and before eventually receiving criticism about its design aspects. But now today, we encounter sort of the opposite behavior as there get to be more screens in our built environment, such as in places where on a car you might have previously pressed a button to access certain features in the car, but now in increasing number of contemporary cars, the buttons have been replaced with a touch screen. So there's a type of reverse skeuomorphism taking place where our physical environment is increasingly being represented by these digital interfaces, which are more likely to be able to be reprogrammed and subject to issues like addressability. So then that raises questions about whether where this process of designing the world in order to benefit informational systems began, and what it, as these interfaces become increasingly computerized, we should become more literate about the systems of information that they are operating on and the protocols involved in order to understand the alternative system, which databases potentially use to act on our built environment. So this raises questions, about what types of protocols might be involved in these interfaces, and how, in effect, how the protocols such as building address or floor numbers, when a system is perceiving the world through an organizational protocol like that, how is that world that the system is acting on and interpreting different from our own world that we perceive? So consequently, we need a condition of protocol empathy, imagining how the world is seen from a protocol's perspective, in order to develop more awareness of how these systems work. And doing so, seeing the world through protocols, could potentially allow us to see new places that we haven't seen before if a protocol restricted our access to seeing them, or indeed to see the world in a new way. Thank you. And I will look forward to hearing your questions.
Great. Thanks so much, Chenoe. Questions for Chenoe? It looks like Gordon had a question there in the chat. Gordon, you want to voice your question?
Yeah, I guess it's more like a speculation. If you see meaningful parallels between this kind of interplay between address space and I guess analog space, and these sorts of things do happen sometimes in digital protocols too. Like one that jumps to mind is the NATs in the internet. They've become kind of a piece of critical infrastructure. Basically, like IP address is a series of grouped numbers which allow you to recursively resolve some device on the network. And early versions of the IP protocol didn't actually have enough address space for all the devices that people wanted to put on the network. So the solution was to put these sort of machines called network address translation services that basically like connect the internet to some local network. And this has some funny consequences. The IP address of a device is often not its actual IP address, maybe a little bit like the French numbering system. And when you want to do peer-to-peer connections, like one computer directly connecting to another, you often have to resolve this issue called NAT punching, which basically means finding your way out of this sort of network maze that the NAT has created to the actual address of the device that you're trying to connect with. I think there may even be some parallels in the blockchain world as well. So anyway, I'm just curious if that's something you've reflected on, or whether you had any reactions to this kind of funny way in which it seems to emerge in network protocols as well.
Yes, IP addresses came up definitely as one of the conversations during the program this summer. And that would, I mean, that's on my list of issues to look further into. It sounds like there could be some interesting nuances with how those types of addressing work, and that's interesting to hear about.
Cool. Looks like we got another question from Brett. Brett, would you like to voice your question?
Sorry, just let me unmute myself. Yeah, Chenoe. First of all, I really like this talk. It's fascinating. We've had time to just sort of discuss architecture and different things, through the summer of protocols. But the part, like the concluding part that, sounded fascinating and promising was the part about protocol empathy. And I'm just sort of curious if you're willing to, or if you've had time to think about that or write about that, or if it's just as speculative as of right now.
I mean, it's on the leading edge of my new ideas, which I think I've been working through with the serial series of artifacts, which will go into different case studies of how these issues work in buildings. So I think that's going to be it is one avenue where I'm further exploring how these types of systems work in the physical world in different places. But more broadly, I think that addressing and like indeed a computer's sort of internal perception, so to speak, metaphorically, of the world is kind of a black box system to us as outside observers. So we have to monitor its inputs and outputs and kind of based on those situations, estimate what's happening inside. And of course, that's a complicated process. But I mean, I think that as a general method, looking at how these types of systems work with specific buildings is good, because I can start to categorize them and then focus on specific systems, like this project's focus on elevators, for instance.
Oh, thank you. I won't take up more time. I'll probably just ask more questions on the forum.
Whatever you think.
Cool. Dorian?
Thanks, Chenoe. I'm curious about more like non-contiguous, like topologically non-contiguous addressing of stuff. Like you had the one thing about the game where there's sort of an impossible topology, but I was thinking about like how would that normally manifest? Like, is it like if you've got like one office from a particular department in another building or something like that? Like, is that where you'd go with that? Or are there other kinds of examples of, like just like non-contiguous and like weird topologies that you encountered?
Definitely. One example, which is discussed in my essay, which I was trying to fit into the narrative of this talk, but I didn't quite see how to fit it in, is the proliferation of buildings, residential buildings with so-called corridors, where condo buildings, for instance, this happened in New York City, and it's mentioned in the essay, where, like, since the city required them to provide a certain percentage of affordable housing, the developers would decide to place that housing, they claimed, due to the zoning restrictions at the time, in a space with a separate elevator shaft and separate lobby to access it, and indeed a separate address. So then you have two buildings, effectively, logically speaking, two buildings with two different addresses inside the same building envelope.
Mm. Yeah, I live in one, but the other one's a hotel, piece is a hotel, and you can't get to the other side of the same. It's in one tower though. You can look outside. It's one tower. So it's a weird. Yeah, it's two buildings, but it's one building envelope. That's interesting. Thanks.
Venkat, you have a question.
All right, I have like an example to share and a suggestion for you, Chenoe. The example is kind of a slightly different one. The building I live in right now, it's an apartment complex that's within kind of an outdoor mall. And the physical structure includes both like a retail restaurant space like many do, and the residential units, but they're all on the same fire system. And we keep having these false alarms. So at some point, they kind of like did something to segregate the fire zones of the retail space from the residential space. Because at one point, one of the restaurants had a little kitchen fire, and that was more serious than the false alarms. So it's all getting mixed up. So it strikes me that there's a slightly different sort of like lens to look at these addressing schemes, which is from the perspective of utility services like fire, water, electricity, and they probably want to partition the space in a more functional engineering access way. And similarly, like I've lived in several buildings where unfortunately they have like poorly segregated fire alarm systems where they're not able to isolate the location of the fire immediately. So the alarm goes off on all floors. So one of the big upgrades my building seems to be doing right now is a different kind of fire system where if there's a false alarm, it won't like cascade through the entire complex. I don't know how they're doing it. So that's an interesting, I think, money trail for you to look into. And the suggestion I have is your discussion of seek times and various computer storage devices reminded me of this sort of abstraction programmers use of like, loosely there is sequential or serial access memory versus random access memory. That abstraction, if you go down deep enough into the physical details, is basically bullshit because, even random access memory does require like physical time to access, and different parts of like RAM memory chips actually take different times to be retrieved. And there's like this famous sort of cheat sheet by Jeff Dean, who's the sort of like legendary engineer from Google, which is basically, I'll actually share my screen and show that because it's, I think, interesting for everybody interested in this topic. Let me quickly find that. Yeah. So I think it would be awesome if you could make a table like this for the built environment. So this is like stuff that extremely low-level engineers have to deal with, who are writing operating systems, kernel code, and things like that. And it's becoming more and more important with AI computing because AI computing is basically a big traffic jam down at the chip level between like, high bandwidth memory, DRAM, various levels of cache, all that. So it's like moving a lot of stuff around, and all these latencies matter, even though none of it is like old-fashioned tape drives or magnetic disks. It's all semiconductor memory, but still you have to keep all these kinds of memories, access numbers in mind. So it would be awesome to see, I think, like a table like this for physical environments, like, typical number for traveling one floor in an elevator, typical number for a dead space type of like skipped floor thing. How long does it take to walk a block physically? How long does it take a delivery truck to go to, I don't know, a delivery zone? It would, I think, be extremely fascinating to have such a table. And also, I think you'd simultaneously nerd snipe architects and computer scientists and get them talking to each other. Anyway, that's just a thought, sorry. And I posted this table in the forum link if you want to like respond there.
Those are all very interesting thoughts. I think regarding the first idea about different types of services in a city, one avenue I was looking at for potentially thinking about that, which could be further developed, would be looking at university campuses, maybe as a specific space, a specific case study where many types of building systems might be interconnected, such as if the university had a particular cooling plan, for instance, that was shared between multiple buildings. It was interesting how I heard about, as part of this research, how fire departments in different cities will have their own kind of records of access and circulation in different buildings. So they might have more complete documentation of where the different elevators in a building go than the general public. So that made me think that that's a potential perspective to think about in terms of seeing cities or buildings in terms of their services. So that's a very interesting and viable angle for further research. Then regarding the second part of the issue of latencies, that's also very interesting. My initial thought would be that I'm curious, with the built environment, there's going to be a wide range of different locations and circumstances and cultures, and also different building users. So I would imagine there would be a wide range of different latencies. I mean, compared, for instance, obviously different elevators will have different types of technology, though there are some sort of standard expectations of how fast one might travel. Floors are relatively standard, but people might walk at significantly different speeds down a city block. So the variety of different types of latencies would be something to keep in mind. And of course, there's also a different variety of computer systems that occur in the world, but programmers working on one type of problem with one type of system they commonly use might, I don't know, have more consensus about the latencies involved. So that would be something to discover, whether or not like that there's issues with the diversity of different latencies that programmers encounter. I guess it also depends on what they're programming.
Great, thank you, Chenoe. Any other questions or comments? Gordon, any more, would you like to voice any more of these thoughts from your? No? Great.
I'm just lobbing, popcorn thoughts. Chenoe's
Fair enough.
pieces always give me a lot to think about.
All right. Well, if we don't have any further questions or comments, I think we can go ahead and wrap it up. Thanks again, Chenoe, for your great presentation on your research project. And yeah, we will see you all in 2 weeks for a talk with Yancey Strickler. Same time, same place. Thanks,
Thank
everyone.
you, everyone. And I'll look forward to continuing this conversation on the discourse forum.
All right. Bye-bye.